Here it is, the Bridge of Death.
Oh, great.
Look, it's the troll from the Lost Treasure. What's he doing there?
No, he's the bridge keeper, the science troll. He asks a traveller 3 questions. The one who answers correctly may cross the bridge safely.
What if I get a question wrong?
Then he casts you into the river of eternal shame.
No, not that. And what does he ask about?
In autumn, he asks about light and your favourite colours. Unless the troll guidebook is lying to us.
About light? Why didn't you tell it right off? That's easy.
Stop! Who would cross the Bridge of Death must answer me these questions 3, ere the other side he see.
Ask me a question, Bridgekeeper. I'm not afraid.
What is your name?
It's Fairy Iridessa from the Pixie Hollow.
What is your quest?
I'm looking for pixie dust. I want to help my fellow fairies.
What is your favorite color?
Yellow and orange.
Nuh-uh. What is your favorite color? According to the subtractive color model.
I don't know that.
Oh! Our world is colorful. But why are leaves yellow, apples red, flowers blue, and some fairies in the river green? Let's start with light. Light is a tiny part of the electromagnetic spectrum that we see. If a lamp radiates light of all visible frequencies, it appears white. The paper also appears white if it evenly reflects the light of different frequencies. Now, let's apply some blue paint. What happens, eh? As you might guess, the blue pigment will reflect the blue rays and some green ones, while the yellow and red will be absorbed. And what color do we get if we mix blue and yellow paints?
It's green.
Right, and why? Simply because the yellow pigment reflects the yellow light and a bit of the green and red as well, but it stops the blue light. The same thing happens if we pass light through blue glass and then through a yellow one. Only green photons will survive. They bounce off the paper and we see them. The more paint, the more photons shall we subtract from the light. That is why we call this color model subtractive. It comes from the Latin subtraho. So when we mix watercolors, we always get darker colors. We can only absorb more photons without adding new ones by magic.
So what's the point in this model?
Oh, it's crucial. I have already mentioned pictorial art, but color printing works the same way. Let's apply a layer of cyan color, add magenta, yellow, and finally some black paint to the paper. That's the way colorful drawings and photos are printed. You came out pretty well here.
Iridessa, hold on! We'll get you out of there!
Stop! Stop! Who would cross the Bridge of Death must answer me these questions 3, ere the other side he see.
I will, you bet your life.
What is your name?
Fairy Tinkerbell.
What is your quest?
I'm looking for dust for fairies from the Pixie Hollow.
What is your favorite color? According to the additive color model.
Ha! Let me tell you about that. Colour is biology, not physics. The retina of our imperfect eye is all dripped with photoreceptors. The rods sense the brightness, while cones, well, it's not so simple about them. There are 3 types of cones. First, perceive the red colour. Second, sense green. And third, react to the blue colour. But wait, where are the cones for orange and teal colours? There are none. Yellow light excites both red and green receptors. We call such a mixed signal yellow. The eye sees no difference between mono and polychromatic light.
What did you say?
I mean, we can't distinguish real yellow light from a mixture of red and green. Hence, we only need 3 coloured spotlights to trick the vision and show any colour. For one, orange or teal. And if we mix red, green and blue together, we get white. Only thanks to such imperfection of the eye, projectors and monitors that show a pretty plausible picture with millions of colours appeared. The screens glow, lighting up red, green and blue dots. The light adds. That's why the model is called additive. From Latin addo, add.
So how can we write your favourite colour in the red, blue, green model?
Green is written like this. 0200 0. Wait, in what model? No, it's the other way around. It's... Hey, that's unfair. You said it on purpose of fooling me. My answer was totally right. Red, blue, green. What a dirty trick. It's red, green, blue. Hey, get me out of this mud and apologise. Right, and get out Iridessa as well. She called the colour correctly. Yes, she didn't tell you about the subtractive model, but hey, she's not supposed to know that. After all, we're not going to art class, you know. The lightning struck our home tree, that's why we're here, looking for pixie dust.
Who must cross the bridge of death must answer me these questions 3 and the other side see.
Go ahead, might as well, since you can't scare anyone. More pressure next time, you almost got him.
Listen carefully. I won't repeat twice. What is your name?
The Empress of the Wind, Fairy Vidia, from the Pixie Hollow.
What is your quest?
Hunting for pixie dust. I'm dying to fly again. What? Are you suggesting that I lie and to take a mud bath with you? It's true that I just want to fly. And yes, if I prevail, I'll share the loot with the others. Can't wait to leave this swamp.
What is your favourite colour? And what is its wavelength?
What do you mean? Mono or a polychromatic light?
Let's say monochromatic. Tell me the wavelength in nanometers.
It does not exist.
A colour without wavelength? I don't think I know that. Huh?
Let me explain. Every rainbow colour has its wavelength. But wait a second, where are pink, magenta and my favourite purple colours then? Not here, and not there either. Does it mean that my favourite colour doesn't have its wavelength? Not quite. Tink said it right, that colour is biology, not physics. And your colour wheel is a big hoax. If we try to roll the rainbow in a ring, where are we supposed to fit the radio waves, microwaves, X-rays and other stuff? Oh well, since we don't see anything of this richness, there is nothing left but to substitute all the variety with a purple colour, or rather with a mixture of red and blue. In other words, purple is minus green. Get rid of the green part and you get my favourite polychromatic purple colour. And please, do me a favour, stop drawing rainbows with purple colour. There is none. Next time, when you see a rainbow, take a closer look. You'll find a violet stripe, unless you have problems with colour vision, but not a purple one. Technically, raindrops may arrange in a sophisticated way, and after all reflections, we might see a bit of pink after all. But such an event is extremely rare. By the way, if you like science fiction, keep in mind that there are no purple lasers. Purple is always a mixture of red and blue. Looks like I'll cross the bridge after all, and you, my fair troll, will sit in the, how did you call it, river of eternal shame.
Why? Why is it called so? Is this dirt unwashable?
Ask Vidia.
How am I supposed to know that? No, don't you... take you...
It is not hard to wash it off. Unfortunately, our shame will be remembered till the end of time.